Another method we're going to use to solving quadratics is by square root. So the first method was factoring, the second method is the square root method. So if the equation's in vertex form, or if there's no x term, you can solve it by taking the square root. So some examples, some real basic examples, and all we're doing here is getting the x by itself. So I've got x squared minus 9 equals 0. I've got x squared plus 4 equals 0. Those are two different problems. All right, so in this one, to get x by itself, I just add 9 to both sides. I get x squared equals 9. To undo the squared, I would take the square root of both sides, and x would equal positive and negative 3. You can't forget that positive and negative. It's really important when we're solving these. All right, over here, I did the same thing. I subtracted 4 from both sides. When I take the square root of these, remember what we do with that negative. A negative under a radical means the letter I. So here we go with our complex numbers. This is where they're coming into play. So I've got x equals plus or minus 2i. All right, so we can't forget that I. So it's important to remember both signs when taking the square root. All right, so here's why. If we have it in vertex form, all right, we're still just trying to get x by itself, so I'm going to undo it one at a time. I'm going to add the 16 to both sides. So at that point I get, before these little square roots come in, I get x plus 2 squared equals 16. To get rid of the squared, I take the square root of both sides. So that just leaves me with x plus 2. It's nothing fancy. The square root gets rid of the squared. So x plus 2 equals plus and minus 4. That plus and minus means that x plus 2 equals positive 4, and x plus 2 equals negative 4. So I have to treat them as two separate equations. So I get x plus 2 equals positive 4, subtract the 2 from both sides, x equals positive 2. X plus 2 equals negative 4, when I subtract the 2 from both sides, I get x equals negative 6. So both of those are my answers, just like if I would have to have factored it. All right. So you might be asked to complete the square before you use the square root method. Don't let this freak you out. You've done it. It's just a fancy way to say take it from standard form to vertex form, then use the square root method. This may be needed if it's an equation that's not factorable. So an example, and this one does happen to be factorable, but we're just going to use this as an example. As an example, I've got x squared minus 4x plus 3 equals 0. So you could plug this in your calculator and get it to vertex form, but if you'll remember, what we did is we focused on just this part right here first. We separated it out, and then we said, okay, half of negative 4 is negative 2, and we wrote x minus 2. 2 squared is 4, so I'm going to subtract that off over here, and then 3 minus 4 is negative 1. So that's just how we did it by hand. So now we can use the square root method. So I've got my x minus 2 squared minus 1 equals 0. I'm going to add the 1 to both sides. X minus 2 squared is 1. So when I take the square root of both sides to get rid of that, I get x minus 2 equals positive and negative 1. So this means that x minus 2 equals 1, or x minus 2 equals negative 1. I'm going to add 2 to both sides in both equations, and I get 1 plus 2, x equals 3. Negative 1 plus 2, x equals positive 1. Both of those are my answers.